Now, guys, when we talked about this entire thing the day before, that means the last class before the Saraswati Puja, we had talked about all of these arrays and stuff, but we've only dealt with a single line arrays. That means just one row that is in so many columns. You can imagine that if an array is of size say 10, okay, so it's actually like this. If you have an array which is, if I write an array like this, say let's be dealing with character arrays, so let's say char, and it's the same with every array really. So let's say that we name it char array. Now in this case char array, and then we give it a size of, let's say 10, or rather say 5. Let's deal with a small one. Let's say 5. Okay. So when we say char array 5, here you must imagine that, see, we've only got here on it this one row of characters. Okay. So basically we're dealing with only one row, okay, of characters. Okay. And with how many columns you have? You have one row, obviously, because it's left to right. But then columns is obviously top to bottom. So top to bottom is columns, right? So how many columns do you have? You obviously have, so 5, okay, 5 columns. You have 5 columns. Okay. I will make you visualize this further. So you have, if I can do it like this using box, 1, 2, 3, 4, 5. Okay. So let us put some characters into it. Say A. Okay. So B, say B, and then let's say C, then let's say D, then let's say E. Okay. So these are your 4, but rather 5, characters. 5 characters. Obviously, once again, let me repeat myself here that we've got 5 elements inside this array. 5 elements, okay, and indices. So indices, your 0 to 4. That's very easy. We've already done this, and you can imagine. So this A to E is actually one row, but there are 5 columns because A is in column 1. Well, column 0 really. A is in the first column, B is in the second column, C is in the third column, D is in the fourth column, and E is in the fifth column, which actually signifies that we have, this is your, if I can just put a bit of a blank in between these, okay. Now or rather, let's just say, let's go back to the previous one. So this is basically A is your okay. Now A is column 0, okay, and B is column 1, and C is column 2, okay, and D is column 3 and E is column 4. Okay, so I hope you realize this. So there are 5 columns. Each column has index 0 to 4. Each column has index. Each column has one particular index, and that it starts from 0. So it's column index 0 to column index 4. But the row index is what? The row index is actually 0. So there's row 0. The row 0 contains 5 columns, columns 0 to 4, and each of these have one element each, and these elements are A, B, C, D, E. But sometimes we need to deal with multidimensional arrays. For example, if you're doing matrices, okay, which is a part of your syllabus or which is a part of your course outcome. If you want to do matrices, okay, then how do you do matrices? You have to present it as a two-dimensional array. So the two-dimensional array, how is that represented? So now let's look at a 2D array where you have array name, and then you have 2 instead of 1 pair of box brackets. First one is always row and the second one is always column. Okay, so we have for a three rows, 3 column character array is given by this. Char, let's name this as a char 2D or say 2D array. Okay. Char 2D array. If we're dealing with only one of these, just name it that. If we had 5 of those, we could name them char 2D array 1, 2D array 2, 2D array 3, etc. Or in particular, sort of, if you had any particular uses for those, then you could have written those. But let's just keep it at char 2D array. So how are we going to name this? How are we going to create this? So you've got row and you've got column. And how many columns and rows? We've got 3 rows. I've got 3. Okay, let's change this to 5. Let's say, okay, let's change this to say 15. Now I want, or rather, let's say that I want a string of length maximum 20 characters. Okay, so I want 21 columns. Okay, 21 columns. Why 21 columns? You can imagine why 21 columns. I've told you this before. Sorry. Okay. So 20 characters okay, for the string 1 character for EOS. Simple. And the declaration also very simple. So box bracket open, box bracket close, and obviously we put a semicolon here because we are ending the declaration. So we put a semicolon there. And what have we got here? We have 3 rows, 21 columns, 3 rows, 21 columns. Now, if you want to put in some values in there, how would you want to do that? Well, the method is pretty much known to you by now. You get yourself a counter. And so let that counter be called int loop C1, or rather a bit better, loop, maybe we'll use several loops, so loop 1 count. Okay. Let us initialize this because I've got a penchant for while loops. You can do it with for loops also, there's no problem. You can do it with for loops, you can do it with do while loops. Okay, whichever way you feel comfortable, you use that. Just remember that in do while loops it's exit controlled, so mostly the checking of whether the loop should go on or not actually appears at the end. So hence it's generally used for those purposes where you do first and then check later. Whereas with the for loop and with the while loop, you have the, you can check first and then do it later. Now, let us input values into our dear 2D array. While, sorry, so you first obviously said this, correct? Now, very simple. You need to use, so this is a loop for what? See, you've got row and you got column. Simply, how do you do this? You could do it row wise or column wise. Now you see, if you use column wise, that means along the column. You first do one column each time. But you see, we do not write like that. We write from left to right. We do not write from top to bottom. If you were Chinese, the Chinese write from top to bottom. Then column wise in this case would have made sense. Here, obviously, we are doing a just simple C programming, and we are using English strings. And English, like our own languages, we write it from left to right. So that is we finish one row, then we go to another row, then we go to another row, then we go to another row, because row is left to right, it's the vertical one. So you go from left to left to right, and then left to right, and then left to right, and then left to right. That's how we do it. And so you see, simply that's what it is. So we are going to do it row wise. So how do you want to do it? Imagine you've got, let us just visualize this array. So let me use a particular, so this looks like this. Like that. Next line looks like this. Next line looks like this again. Right, so this is your array, 2D array. This is how you can visualize your 2D array that you have. Now, as you know, this and this, these are block comments. These are line comments, these are block comments. So anything within this is considered as a block. So basically, let us say I'm writing all sorts of things here. So for example, A, and then C, C, and C, E, and here I'm writing, say, B, and then these are all just spaces for one character. Okay. Like that. So all these characters are there. So this is your row 1. This is your row 2. And this is your row 3. And this is how it all looks. The first row has 3 characters, A's. It may have some more. That is why the ellipses are there. I mean, how many are there? Basically, there is up to 21 characters. Now obviously up to 21 characters, but the point is that we're going to leave, so we're going to just 220 plus end of string. Same it is here. Okay, the same thing applies with these as well. Right, and the same thing applies with this as well. Right, so we have got this row and all these, and these are all the columns. So these are all the columns. So you can see this is your column 0, and up to that, up to this is basically up to column 21. I beg your pardon, sorry, column 20, right? So from 0 to 19, we are going to put in the characters, and we're going to leave one behind for the end of string. If we do take the 21st character, that is index 0, 21st character is at index 0. So if we do take the 21st character, that is the index 0, with many compilers, when you are printing them out as strings, you may have a garbage value right at the end, because as a string, it would actually have to put the garbage value in there. So rather than that, rather than avoiding having to put the garbage value in there by the compiler itself, we just leave it some space. We leave it one space at the end. So, but anyways, the columns are from 0 to 20, and here I might as well write it for you, that we have column 0, rather just in caps, say column 0 to 19, and then we have E O S. So this is how it actually is going to work. This is the arrangement. So you can see that there is row and column. Now first we have to fix one row, write in all the values in there. Then we have to fix another row, so that row is over. Then we have to fix one row, and then we put in the values. Then we have another row, and then we put in the values. Okay. So how do you have to do that? Well, if we are going to pursue the character by character input method, that is the arrays elements are put in index wise, that kind of a method, if we are going to pursue, we need a simple scanf. Now, but here we need a count to count the loops, count the rows. So we have loop 1, count, beg your pardon, loop 1 count. While loop 1 count now it starts from 0. How far does it go? Well, it starts from 0, so it goes up to 2. So is lesser than, we can say lesser than 3. You can say lesser than equal to 2, or you can say lesser than 3. Either way it will work. So this loop count is for the rows. So this is for the rows. But you see, once we have got to the row, before we go to the second row, we need to fill in all the columns. So we need to repeatedly put in values inside the column. Okay, now let's just reduce this. No, fair enough. Let us just reduce this simple bit. Say okay, fair enough. What we're going, let's say that we just keep it simple. We'll just keep it simple. Well, okay, let's remain it. Let's put it at 21. Now thing is that so we have to put in values in the columns. So rows being fixed, we need for each of the rows one loop to put in values into the column. So once again, once we go to one row, okay, then we need another loop to put in values repeatedly in the row along the column. So we do that. So we need another while loop. But if we need another while loop, we need another count. So int, beg your pardon, int loop. Remember, this is a inner loop. Loop inner count. Don't want to use loop 2. Why? Because this is the loop within a loop. It's called a nested loop. So loop inner count equals to, I'll say, 0. Okay. In fact, we can do much better than that. We can just change these to loop 1. Let's be very specific, loop 1 rows. If we use several other loops, as we will do, so loop 1 columns. So this is for the columns. That seems to be much better. Now this one has to be changed to loop 1 rows. Then you can imagine better. So loop 1 rows, we have studied it from 0. While it is greater than, rather whether it is less than 3, what we do another loop, and this time we need a while loop again. Well, any loop really. So let's first do the syntactic bit so that we are not left wanting for that. Later on we might be held up for just that. So while, and this is for the entry of the loop. Loop 1 columns. Okay, and this is what it has to be lesser than 21. Yeah, so 21 actually, so we can go up to 20. Actually, we will not go up to 20, we'll go up to, we'll go less than 20. I'll tell you what the reason is. Because this is index, right? So you go from 0 to 20, you go up to 21. But we only want to enter up to 19. Why we enter up to 19? Because once again, 19 means that we have index 0 to 19, that's 20 characters. One character is left for the end of string. So for each row, there has to be one end of string character. So that is there. Now, with a simple scanf, and just we use the conversion character here, and the conversion character is %C, and what we do is the address, and how do we do that? And %. Let's name the array now. Let's put a small space in there. Remember, do not ever, I'm putting this small space, this is just for readability. There is no space inside the double quotes of a scanf. It will give you a lot of problems, okay, as you've perhaps already seen. Do not ever put a space between the double quotes, in between the double quotes, %C, %D, whatever. Never put a space in there, ever. Now we have, we're putting it in cat2d array, so cat to d array, and we need 2 of these. First one is rows, so we have loop 1 rows, and the next one is columns, obviously. So we have loop 1 columns. Now I'm writing this in a notepad. When you are actually transferring it, you must remember that although see the free form language, it does not allow you to break between statements. Okay, so here when you paste it, I am to paste it in the editor. When you paste it, then this is the row index, is the column index. Here, because of the want of because it's text wrapped, it's come to the next line. When you print it on the editor, this should be in one line, otherwise it won't work. Well, it should not work. If it does work, then it's a very weird compiler. It should not work. Anyway, so there we are. Now let us say we have we have to print it out as well. So just to check what we have actually done. Sorry. One thing remains. Now we need to, after this, move up the loop columns, loop 1 columns. So the loop 1 columns is moved up by ++. You can simply do loop 1 columns equals to loop 1 column. Loop 1 columns equals to loop 1 columns plus 1. That is also very helpful. Now, and this inner loop has actually covered the what? This is for the column entry. Okay. Or rather, we should say, to be very specific, this is the column wise advance. That is done. Okay. Now we have we've come out of the column wise loop, so all the columns are now in one row. All the columns are full. In the next row, all the columns are empty, and in the next row also all the columns are empty. So go back. Now we do loop 1 rows. Now we have to move the rows up. ++. Okay, so this is the outside the inner loop. So again the outer loop, and it's nothing but the row wise advance. Okay. The printing of this is again very simple. Just take this, we repeat this. Bullshit. We just take this entire thing, copy this, paste this. Now here obviously you don't have int anymore, there is no more declarations. Obviously using loop on rows and loop on columns again, and instead of scanf we'll have printf, PRIN God, printf, print f, and these two must go. So printf. Let's put a small space in between. Okay, let's not put any space in between. Fine. Now, once this has happened, there's something else. So we need to put the row in a separate line. So once the loop printing has been done, we need a separate printf statement. Oh, stop. And obviously we need an open bracket and a closed bracket and a semicolon. And here we have to do a new line. Great. And now you ask, those of you who are seeing this for the first time, you may ask me, why have I actually put a new line in there? Because obviously we want the entire, if you put it in there, the column elements are going to be put in separate lines. That we don't want that actually. We want the rows to be separately printed, okay? And let's just see if this works. It's a lot of code, so let's just see if this works. So here we are. Now we are not using this character array for the timing. Let it remain like that. This 1D character array, we are not using it for the timing. Let it remain like that. So follow this, okay. Now obviously we need a small now obviously we need a set of inputs. So let's just do the inputs first. So C V B N G blah 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 blah. We need 21 of those. Blah blah blah. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And we can do 20 of those, obviously. But if it's a string, this is not a string input. This is what? This is basically a character-wise input. So another entry. Oh, sorry, this one sec. Something was wrong. Oh yes, oh yes, oh yes, oh yes, oh yes. I'm so sorry. So sorry. Put an ampersand there. That's not the right thing to do, obviously, because we don't need ampersand there. And now, let's say A, B, C, D, E, F, G, A, B, 1. Let's see what happens if we do all of this together. There's so many of those together won't be taken. So taken only up to this one. Let's see why this happened. All right, let's run this again. Let's say we have C, D, E, F, G, H, G, I, J, K. Okay. So basically, the problem was actually with loop columns. Okay. So actually, I have to put it inside because you know what is happening is after we reached 20, this inner while loop will not work. Now, obviously, it was reaching 20, and after that, I was not resetting it. So that's what it is. So I'm resetting it now, resetting it here, and resetting it there too. So let's run it and let's see what happens there. So you see, we are going to read. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. Okay. One. Second one, V, W, X, Y, Z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 star V W X Y Z 1, 2, 3, 4, 5, 6, 5, 4, 6, 9, 8, 7, 0 star. Let's put this and this and this and this, and the next one we put a fill it up. Okay, there we are. And this time, obviously, the next three V's after the GCCC, you can see that here there is a branching off, because obviously this was perhaps F F F D D D V V V C X S F G C C C V V V. No, it should have taken. I don't know why it's not given the last ones, but the other ones were pretty much accurate. Anyways, imagine this, that the special characters are also characters. Oh, acha, sorry. Yeah, no. The special characters you see are also characters. Okay, so the word. And the 1, 2, 3, 4, 1, 2, 3, 5, 4 are these are also characters here. These are just numeric characters. Characters can both be alphabetical, which is A to Z, capital A to Z, or can be numerical, 0 to 9. They can also be special characters like star and then exclamation sign and then ampersand and then at the @ sign and dollar sign. All of these can be characters as well. So got it. Okay. So let's try to run this again. Run. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, U. Okay, and then let's do it numerical. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, in the previous one, I've actually given in 21 characters. I'm sorry, that's exactly what happened. So 21 characters. And that's fine. I can give in 21 actually. That's 0 to 9, that's 10, 10, and then another one's a 5. The next one, I put in all this kind of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20, and then 21. Let's see what we have. All right, the last line, we have some problems with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And it's only giving us 16 of those values. Somehow, the last line is not being fully printed. Got no reason why it should do that. But let's just check the program and try. Okay, so it's still not, actually, let me fine tune this a bit more. So I'm doing this and I'm keeping this steady at 0, because obviously you're starting with column 0 at each of those rows is starting with column 0. So I'm giving it loop 1 rows plus plus and then column 0. That should work. Let's just run it. Have some A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, then 15 of those, so plus just 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's see. Okay, it's still taking this together. I mean, it's taken the second line together, and it's okay. Let's just try this. Okay, let's just try to flush out whatever is in the pipeline before we start off again. So when we do printf, what we want to do is I want to just try something. I want to just flush out the standard output file. As you can imagine, if you remember from the very first days, standard output file is the file where the program keeps the variables, or rather the values, before they are printed out to the standard output. So let's just see stdout. That is the designation of the standard output file. Because I'm using strings, it becomes a bit more. It becomes a bit complicated for the computer to handle. So basically, if I'm just doing flush stdout, that actually what it does is it flushes out whatever is in the pipeline. So let's just do that. Run it once again. A B C D E F G H I J K L M N O P Q R S T U V W X Y Z, and then 1 2 3 4 5 6 7 8 9 0 0 9 8 7 6 5 4 3 2 1, and then we have 1 2 3 4 5 6 7 8 9 10 12. Well, sorry to say, the process is basically the same. I've got to look into it a bit more, but I think it's taking both the strings of row number 0. And it's after the first one, it's taking the two strings together, first row number 0, and then it's coming back to row number 3, which is row index 2, that's row 2, and it's printing it out separately. Should have done it that way, but this is what it's doing. But anyways, that has to be further checked. But for the time being, this is what you can do it with a string sort of. You can use it as a string. We can see we have already seen this here. We use this as character, so this as strings. So I guess we didn't leave it enough space for end of string. That is why it was doing it. In fact, that is exactly why it was doing it, because with characters, end of space does not matter. But when we are entering this, we are actually entering 21 characters times 3 without entering any end of space. So because we are not entering the end of space there, it is mattering. Okay, it's taking the matter to heart really, and so that's exactly why it cannot determine the end of space there. Now that's why it is creating a bit of a problem. But otherwise speaking, this is what it is. Okay. If we had entered the end of space, and this goes on to show how how much you need the end of space. Okay. Now we can obviously go back and do the same thing with scanf. So sorry. So copy and create a bit of space there and paste it here. Now what we're going to do is we are going to use scanf instead of printf. And obviously we're going to get rid of all this extra bit here. And instead of stdout, we're going to flush stdin, standard input file, or stdin. It refers to the standard input file. It is where your inputs go in before they are taken to the program. Okay, so when your program is drawing inputs first go into the standard input file, and then from there it actually goes into the program. So we are going to just empty the stdin before we start to do it again, and then we proceed as follows. Let's get rid of this extra bit there. I don't think it's necessary to run it. So A, B, C, D, E, F, G, H, J, K, L, M, N, O, P, Q, R, S. I keep on doing that for good. That should be about right. Oh, there's some more to take. Okay. Now it's expecting some more. So we need some strings in there. Hello world. Spawn string. Right, so here's the run. Okay. So this time I counted, right? As you can imagine, that what was happening before was that I was using a space. Now, that's a silly mistake, obviously, because a space would be obviously used as a it would be used as an end of string. So here we are. No, let's just run it again. Once again, our 63 characters. Start up with this QWERTY, this time around QUERTYUIOPLKJHGFDSAZ XCVBNM, and then our 1 2 3 6 like this. So we got 4 rows of those, and then we have 3 of these, and we have this. Now this part is clear because actually we are printing out in characters. If you go 3 strings, hello space world space howdy, that's a short for how do you do. See, it actually does keep the last one. Yeah, it probably was a bit of something that was wrong with the countering. Now you see, this is what it is. Here, when I'm entering the values, the close parenthesis there, okay, that one you can see this one here. This one here, the close parenthesis and the this one here, the close parenthesis and this semicolon was extra, so that would have been taken in for the next input. So when I see that it's printed out only here up to here, I imagine that the bracket close, that means the parenthesis close, and the semicolon would be for the next one, and then I only provide it with 2 strings, RT and NM. Okay. Now as you can imagine, the space means end of string, so basically we have 2 strings, RT and NM. Now we have actually 3 strings. As you can see, the end of this bracket, this one here, okay, the bracket and the semicolon, which was extra from the other other input, that one is taken in as the first string, and then RT and then NM. Why does this happen? Because whenever it is extra, okay, you are putting in some values and it is already nested in, but you are actually taking it up to a certain amount, and the rest amount is left into the SAD. Because of the loop counters, the last 2 characters, which is the first string that is printed here, the bracket end, and that is the parenthesis end, and the semicolon taken together, those were in the STD in, but they did not go into the character array. Okay, so that one, when it was the time for the string to come in, it actually took it in as the first string.